Okay, in this video I'm going to work out the solution to most of the questions, or if not all of them, the questions from the final exam study guide. I'm going to begin with question 1. Find the area under the standard normal curve between z equals 1 and z equals 2. So this is what we need. We need a probability of z between 1 and 2. If you go to your calculator, you go to second, distribution, and it is a normal CDF. Enter. Okay. Lower bound here is the lowest value of z is 1, so I need to change this 1 to 1. Enter. Upper bound is 2. And since this is a z-score, the standard normal curve, you leave mu at 0 and sigma at 1. Paste and enter, and here's the answer. So I'm going to write down the calculator function that I used here. Normal CDF. Lower bound is 1, upper bound is 2. The mean for z is 0 and the standard deviation is 1. And if you press enter, I'm going to round the answer to 4 decimal places, so it will be 0.1359. So that is question number 1. Question number 2. The length of time it takes college students to find a parking spot in the library parking lot follow a normal distribution with a mean of 3 and a standard deviation of 1. Find the probability that a randomly selected college students will find a parking spot in the library parking lot in less than 2.5 minutes. Okay. So number 2, we have the mean to be 3 minutes. Standard deviation sigma is 1 minute. And we need the probability of x less than 2.5 minutes. Okay, if you use the calculator, it is a normal CDF. Okay, let me go to the calculator again, second, and distribute. Normal CDF. Okay. Less than 2.5, so that means the maximum that we can get to is 2.5, but the lower bound can be as low as we want, so I'm going to make it negative 100,000, negative a million if you like. So you can do negative a million. The calculator has negative 1 with 99 zeros, but this is good enough. Upper bound is 2.5 because we cannot exceed 2.5. The mean is given what here to be 3, and the standard deviation is 1, so we'll just leave this 1 and then paste and then enter, and here's the answer. So we have negative a million. You want to put negative 1,000, it would work. 2.5 is the upper bound, comma, mean is 3, standard deviation is 1, and press enter, and your answer is going to be 0.3085. Question number 3. A physical fitness association is included in the mile run in its secondary school fitness test. The time for this event for boys in secondary school is known to process a normal distribution with a mean 440 seconds and a standard deviation of 60. So the mean is 440 and the standard deviation is 60. Find the probability that a randomly selected boy in secondary school will take longer than 302 seconds to run the mile. Longer than. All right. Okay, so the mean is 440, sigma is 60, and we need the probability of x equals 302. So it is a normal CDF again. Okay, the lower bound is the lowest value of x. Well, he says x must be bigger than 302, so the lowest value it can take is a little bit more than 302. So we start with 302. Upper, anything bigger than 302, but you have to go as high as you can. I'm going to use a million here. Mean is 440, and standard deviation is what, 60, and close. So let's see what the calculator does here. So I'm gonna go to second, variables, normal CDF, enter. Okay, so that's a 302. Then 1 million, you can put 100 million here if you want. And oh, I put 100,000. I'll go back and put one more zero just to be consistent with what I wrote down, but 100,000 will do it. 440, standard deviation is 60, paste, enter, and the answer is 0.9893. Number 4, find the z-score for which the area under the standard normal curve to its left is 0.7. So now he gives me the area, the probability, and he wants the z-score. Okay, let's do that. We're going to use the calculator to do that. You can use the table, but I'm going to use the calculator for this problem. Okay, so we have the area to the left of the target is 0.7. We need to find what that z-score is. So this is what it is like if you want to see a sketch of this. Okay. This is half 50. Since it is 0.7, it's going to be somewhere here. So this area, guys, is 0.7, and we need to find this z-score. Well, this z-score, we're going to use a function of the calculator. It's called inverse norm. It's going to require 3 arguments. The area to the left of this number, which is given to us, 0.7. And then since we're finding z, which is a standard normal curve, we put the mean equal 0 and the standard deviation equal 1. So let me show you how to do this. So on the calculator, you go to second and distribute. And then it is number 3. You need 3 arguments, as you can see, 0.7. And by default, it puts 0 and 1 and then paste, enter. It's 0.524, so since we're using 2 decimals for the z-score, so that will be 0.52. That's the answer for number 4. Okay, number 5, the length of time it takes college students to find a parking spot in the library parking lot follows a normal distribution with mean of 3 and standard deviation of 1 minute. Find the cutoff time, which 75.80% of college students, it should be do not exceed. The answer is done as do not exceed when trying to find a parking spot in the library parking lot. So again, I'm going to change, the word exceed to do not exceed, so the answer will match with the one that we have in the last page. Okay, let me show you how to do this. So let's go to our number 5. All right. So the mean is 3, standard deviation is 1. We want the cutoff score for which 75.8% of students do not exceed. So we want this number. This area here is 75.8%. And we need this x value. Okay, we can use inverse norm. And we need 3 arguments. The area to the left of this value, which is 0.758. The mean, which is 3, and the standard deviation is 1. And let me show you how to do the work here. So we're going to go to second and distribute. Inverse norm. Okay, I'm going to put 0.758. And then the mean is 3. Standard deviation is 1. I'm going to paste. And here's the answer, 3.699 minutes, which is about 3.7 minutes. Okay, number 6. The owner of a computer repair shop has determined that their daily revenue has a mean of 7,200 and a standard deviation of 1,200. So mean is 7,200 and standard deviation is 1,200. The daily revenue totals for the next 30 days will be monitored. So we're talking about a sample here. What's the probability that the mean daily revenue for the next 30 days will exceed 7,000? Okay, let's do this. So I'm gonna go back to my sheet. So he's asking what's the probability that the mean daily revenue for the next 30 days will exceed 7,000. He's not asking about one individual date. He says the mean of the next 30 days. So it's an X bar question, so probability of X bar greater than 7,000. Okay. This is a sampling distribution of the sample means. So the mean, when we use the calculator, is going to be the same as the mean, 7,200. But remember, anytime you work with X bar, your standard deviation of the sampling distribution is going to be different. It's going to be the original standard deviation divided by square root of n, which is in our case 1,200 divided by square root of 30. So to answer this question, it is normal CDF probability. We need a lower bound. The lower bound is 7,000 because that's the smallest value. Upper bound, you can make it 1,000,000 or 10 million if you like. A mean is, again, I said does not change, is 7,200, but look here where I'm going to put for sigma, not 1,200, it's going to be 1,200 divided by square root of 30. So let's do this on the calculator. So we're going to go to second, variables, normal CDF, lower bound is 7,000, upper bound, what did I put, 10 million, mu is 7,200, standard deviation, watch, is 1,200 divided by square root of what? 30. And then I'm going to paste, enter, and the answer is 0.8193. So that's number 6. Please note here that the answer in number 6, at the last page was not correct. So, but just follow my direction in the video. Okay, number 7, in a survey of 10 musicians, 2 were found to be left-handed. Is it practical to construct a 90% confidence interval for the population proportion P? Explain. Well, if you find a P hat here, P hat is 2 over 10, which is what, 1 over 5, which is 0.2. And Q hat, which is 1 minus P hat, which is 0.8. In order to be able to construct a 90% confidence interval for the proportion, you must have n times P hat times Q hat greater than 10. Well, n is 10. If you multiply by P hat, which is 0.2, that's going to give you 2. And if you multiply 2 by 0.8, which is Q hat, which is, this is going to give you 1.6. Well, 1.6 is not bigger than 10, so it's not practical. Okay. But if I ask you in a question, construct a 90% interval or a 9% interval, you don't even need to test that because I'm assuming that the conditions are met. So we're going to go to number 8 now. Construct a 98% confidence interval for the population mean. Assume that the population has normal distribution. So we need 98% confidence interval. A study of 14 cars owners showed that their average repair bill was $192 with a standard deviation of $8. Round to the nearest cent. Okay, so we need to create a 98% confidence interval. The sample size is 14, X bar is 192, and the sample standard deviation is 8. So you go to stat, tests. It's a T interval since the sample standard deviation is giving. Enter. We don't have data, we have a summary of the data, so we choose stats. Okay, X bar, what is it, 192. Enter. S is 8. And then move down. Sample size is 14. Confidence level, we need a 98. And then hit calculate. And here's your interval. He says to the nearest cent. So our interval to the nearest cent will be 186.33, comma 197.67. What can you say here? You can say with 98% confidence, we can say that the true repair cost, what was the problem about? Let me just get it again. The true repair bill cost is between $186.33 and $197.67. So that's the question number 8. Okay, number 9, he wants us to write the null and the alternative hypotheses. Okay, this is what the claim is. The mean annual return for an employee IRA is at most 5.1%. So this is what the claim is. At most, what's at most, guys? It's less than or equal to 5.1%. So the condition of equality is in this claim, and this is what's going to be your null hypothesis. What would be the complement of this claim, or what we call the competing claim? It's the alternative statement. So the alternative statement will be, okay, what's the complement of less than or equal to will be greater than 5.1%. So your HO is going to be mean equals 5.1%, and your H1, which is the alternative must have a greater than, less than, or different from. So it's going to be the competing claim, which is mean greater than what? 5.1%. And your claim in this case happened to be in the null hypothesis. Please check the answer in the back. The answer is not correct, and my answer is the correct one. Some of the answers in the back, well, all of them are generated by the computer, but there are glitches sometimes. So it seems like the computer did not recognize the at most properly in there, or whomever just did this exercise did not do it properly. Okay, number 10, a recent study, this is a test for the proportion, claimed that at least 15% of junior high students are overweight. In a sample of 160 students, 18 were found to be overweight. At alpha equal 5%, test the claim. Okay, so we have at least 15% are overweight. 160 were selected, 18 of them were found to be overweight, and test the claim at alpha equals 0.05. At least 15%, you need to know what at least simple means. It means greater than or equal to. Since it has the equal sign, so that must be the null hypothesis. So it's a proportion here, so I just use P equal 0.115. Now, what is the competing claim against at least, and what's the complement of at least? This is what the at least sign here. What would be the complement of this sign will be less than. So our alternative should be P less than 0.15. Now you ask me a question, why did I put the less than in the alternative? Because the alternative must have less than, greater than, or different from. Anything else goes to the null hypothesis and get replaced only by the equal sign. So this is where the claim is. Okay, how do we test this claim? Let me show you on the calculator. It's 1z proportion z test. So stat, turn the calculator on, stat, tests. It's 1 prop z test. Okay. P0, this is the value from the null hypothesis, which is 0.15. And then scroll down. X is the number of successes, which is 18. N is 160. And now, here you choose the alternative, not the null hypothesis, the alternative, which is what here? Less than. Enter. And then hit calculate. Okay. Any hypothesis test, you need the 5 steps. So the first step is to state the null and the alternative. The second step is to state the value of the test statistics. Third step is the p-value. Fourth step, make a decision to reject or fail to reject HO. And the last step, interpret your decision in the context of the claim. So we already have step number 1. Let me put step number 2. Okay, so the test statistics, step number 2. Z was what? A negative 1.33. P-value is what? 0.09. Usually use 4 decimal places. 20, which is more than alpha because alpha is 5%. So what's the decision here? Fail to reject HO. If the p-value is less than alpha, we reject HO. If the p-value is more than alpha, we fail to reject HO. The claim is in HO and we fail to reject HO, so this is what you write. There is not enough evidence. At the 0.05 level of significance to reject the claim. You just say we cannot reject the claim. The claim that at least 15% of the students are overweight. So this is number 10. Again, in number 10, in the answer key, the p-value is wrong. What I'm going to do, I'm going to change, I'm going to try to edit the PDF file and repost the questions.